Okay, so we're going to be talking about how to graph linear inequalities in two variables. Inequalities meaning we have greater than, less than equal to, greater than or equal to. Now, we've done something like this before, except it didn't have two variables. What we had before, just to give you kind of a reminder of what we were talking about, was when, say you have x is greater than 2. And we would talk about how to graph that on a number line. It's one-dimensional, so it's just a number line. We would have 2. And then to show that we want all the numbers bigger than 2, we would shade the line to the right. That shows that all those numbers are part of my solution. Now at 2, we would create an open circle showing that that is where our solution set starts, but 2 is not included in that solution. We're going to do something very similar to that based on the inequality, whether it's greater than or equal to, today on our equations. The difference is our equations today, we're going to be graphing lines, like y equals 2x plus 3. Or y is greater than or equal to 2x plus 3. Alright, but before we get into that, we're going to have a little practice thing. Okay, so what we want to do is see whether or not the ordered pair is a solution to the inequality. So we're going to take each ordered pair, like 0, 4, and we're going to plug it in for x and y, and then see if it's a true statement. So that would be 4 is greater than or equal to negative 2 times 0 plus 4. So 4 is greater than or equal to 0 plus 4, which is 4 is greater than or equal to 4. And that is a true statement. So then, yes, 0, 4 is the solution. So I'm going to write yes right there. Alright, let's try the same thing with negative 1 and negative 8. So I'm going to take negative 8, plug it in for y, is greater than or equal to negative 2 times negative 1 plus 4. Negative 8 is greater than or equal to 2 plus 4. So negative 8 is greater than or equal to 6. That is not a true statement. So negative 1, negative 8, no, that is not a solution. Now the whole reason why we're doing this is because when we graph inequalities, one way you can tell where to shade on your inequalities is to check an ordered pair and see if it is a part of the solution. Okay, a little bit more practice on this. We practiced telling whether or not the ordered pairs were a solution on our inequalities. So we start here. X minus y is less than 4, so I'll plug in the x and y, starting with the 0.54. Alright, 5 minus 4, oops, don't need two of those. 5 minus 4 is 1, which is less than 4. So the ordered pair 5, 4, that is a solution. Alright, try the same thing with the next ordered pair. So negative 1 minus a negative 4. See if that is less than 4. Minus a negative turns to plus positive. So that would be 3 is less than 4. So negative 1, negative 4 is also a yes. Okay. So box those answers in. Okay, let's try another one. Same thing, plugging in the x's and y's. So it'll be 2 times negative 1. It's less than 5 times negative 2 plus 10. So negative 2 is less than negative 10 plus 10. So negative 2 is less than 0. That is a true statement. So therefore, negative 2, negative 1 solution. All right, trying the same thing with the other ordered pair. 2 times y is 2. It's less than 5 times x, negative 1, plus 10. So that's 4 is less than negative 5, plus 10. So 4 is less than 5. That is a true statement also. So yes, negative 1, 2 is a solution. So I can box in those 2 answers. Okay, so now we're going to start graphing the lines for the inequalities. The way we graph inequalities is the same as graphing a line. The only difference is you have to determine whether or not the points on your line are a part of the solution. So if you have a greater than or less than, meaning there's no equal to sign underneath it, you're going to use a dashed boundary line. If the inequality has an equal to sign underneath it, then you're going to use a solid line for the boundary. That symbolizes that all the points on that line are a part of the solution. Okay, so example 2 in our notes says to graph y is greater than or equal to negative 1. Alright, so this is going to be a horizontal line. This is where I have a slope of 0. And it's greater than or equal to, which means that it's going to be a solid line. Now here's where we practice what we did earlier. I'm going to pick a point. I picked the point 0, 0, and I'm going to plug the x and y, which in this case is just the y, into my inequality. If that's a true statement, then I am going to, that means that is a part of my solution, so that means I'm going to color this area above the line. If it's not, then I'm going to color below. So then 0 greater than or equal to negative 1, that is a true statement. Ooh. So that is where I'm going to color. Above the line that contains the place where the point that I just tested is contained. Now I think most of you can kind of tell it's y is greater than or equal to negative 1, so this is where we shade. There we go. Alright, example, x is less than 3. Okay, this is a vertical line. We have an undefined slope, and it's less than, not equal to, so that means the line is not a part of my solution. So I'm going to draw a dashed line. Right where x is 3. And then I want to shade everywhere where my x values are less than 3, so that means I'm going to shade to the left. Scribble, scrabble, as my 6-year-old would call it. Alright, next example. Y is greater than or equal to negative x. Okay, so to graph this line, I'm going to be looking for my slope and y-intercept. My slope is negative 1, the number attached to the x, and my y-intercept is 0. So I'm going to plot a point right at the origin, and then use my slope to get another point. I'll actually use my slope to get 2 points. Alright, now the line that I need to draw needs to be solid because I have the half equal to sign. So all the points on that line are a part of my solution. So draw my line. Now I have to think, where do I shade for this line? I can either shade above the line or below the line. I'm going to pick a point. I'll pick the point 2, 2, and plug those values in. So if I take the ordered pair 2, 2 and plug them in, my x, y value 2 is greater than or equal to negative x, which is negative 2. That's a true statement. So I'm going to shade on the side of the line that contains that point. Now, that's the hard way of going about that. The easy way is to say, okay, the inequality says greater than or equal to, so therefore I'm going to shade above the line. If it were less than or equal to, then I would shade below the line. Pretty simple, really. Okay, so y is less than 3x minus 2. So again, I'm going to use my slope and my y-intercept to find that line. So my slope is 3, or 3 over 1. My y-intercept is negative 2. Okay, so I plot my y-intercept at negative 2. Then I'm going to go up 3, to the right 1. Can also go down 3, left 1, same line. Okay, now my inequality is less than. It does not include the equal to, so therefore, just going to draw a dashed line through my points. Okay, now to decide where to shade, I can think either pick a point, plug it in, or I can just ask myself, it's less than. So am I going to shade above or below that line? So it's less than, I'm going to shade below. Okay, now just to give you an example of that, yes, that philosophy worked. I'm going to pick a point, 0, 0, and I'm going to go ahead and plug it in to my inequality to see if it's a part of the solution. So that would be 0 is less than 3 times 0 minus 2. So 0 is less than negative 2. That is not a true statement. So 0, 0 is not a part of the solution. So I would shade on the other side of the line exactly like I did. So it's going to work every time. So much easier than plugging in the point. All right, on this next example, in order to be able to graph it, I need 2 points. I can either do, x and y intercepts, or I can do slope-intercept form. When I look at this, I think x and y intercepts are going to be easier. So if I cover up the 3y and solve for x, then my x value is 3. So my x-intercept is the point 3, 0. Now to find my y-intercept, I just need to cover up the x, 3y and 6, so then my y-intercept is 0, 2. Alright, so plot those 2 points. Okay, now it's less than, so I'm going to have a dotted line. That's horrible. All right, and then after looking at the inequality, it's less than, so I'm going to shade below. Again, if you don't trust yourself, pick a point. Test it. All right, 4x plus y is greater than or equal to 2. This time, I'm going to graph it by using slope-intercept form because it's really easy for me to move that 4x. So if I remove that 4x, my equation would be y is greater than or equal to negative 4x plus 2. So if I plot my other points, all right, now I need a solid line. Because it's equal to, now it's greater than, so that means I'm going to shade above the line. Okay, so let's practice those absolute values. All right, remember the parent function for the absolute value is y equals absolute value of x. The vertex is at 0, 0. So if I have a plus 2 inside the absolute value and then the minus 1, my vertex is going to be moved left 2, down 1. So my new vertex is negative 2, negative 1. So I'm going to go ahead and plot that point. Erase my other one. Okay, now my I do not have a vertical stretch, so my points are still up 1 over 1, up 1 over 1. And it is going to face upward because it's not negative. Okay, now my inequality says to shade, that it's greater than, it's not equal to. So that means I'm going to have a dashed line, dotted line. And then I need to decide, am I going to shade above the V, above that absolute value V, or am I going to shade below it? Since it's greater than, I'm going to shade above. All right, and then number 9. Y is less than x minus 3, absolute value plus 2. So vertex for a normal parent function would be at 0, 0. This one is going to move to the right 3 and go up 2. So my new vertex is the point 3, 2. So over 3, up 2. And again, there's no vertical shift. I'm still going up 1 over 1 every single time. There we go. And then it's less than, it's not equal to, so dash line. All right, then it says less than, so I'm going to shade below. Okay. Okay, so we did a little word problem. It says you sell t-shirts for $15 and caps for $10. Write an inequality describing how many shirts and caps you must sell to exceed $1,800 in sales. Okay, so we're going to let t-shirts be X and caps be Y. I don't know how much I'm selling of each, but I do know that for each cap I sell, for each t-shirt I sell, I bring in $15. And for each cap I sell, I bring in $10. Now I want my sales to exceed 1,800. Exceed means bigger than, so greater than or equal to. That would be my inequality expression. Okay, now on this next problem we're doing the exact same thing. t-shirts X, caps Y. But it says to explain how you can modify this inequality to describe how many shirts and caps you must sell to exceed $600 in profit if you make 40% profit on shirts and a 30% profit on caps. Okay, so I still am trying to get more than $600. Well, it says exceed. I'm thinking I don't need the equal to sign underneath there. Alright, then I'm still selling the t-shirts for $15, but for each one I sell, I get to keep, what's my profit for shirts? 40%. Okay, and then, let me erase that. I still have my 10 times Y, but I'm making a 30% profit. So 0.3. Alright, so now it's just simplifying that. 15 times 0.4 would be 9x plus 10 times 0.3 would be 3y. Has to be greater than 600. Okay, so on the opposite side of our notes page in the journal, what we did was we answered what does a dashed line on the graph of an inequality represent? All right, and then our assignment for 2.8 was pages 33 through 34 in the workbook, 2 through 20 even.